Hey there, welcome back. This is continuing in college algebra with chapter 2, section 3, linear functions. We're going to focus just on linear functions, lines, and talk about the slope of linear functions. There's going to be some more in section 4 on linear functions as well, but we're going to introduce the basics here today, talking about how to calculate a line's slope, two different forms of the equation of a line, special cases of horizontal and vertical lines, and then some additional stuff. All right. So first of all, what is a slope? A slope is a ratio. It's a relationship that depicts how steep your line is. Okay. So graphically, what that means is a slope that is barely going up from left to right. That's a relatively small value, whereas if you go up like this is steeper, right? So what's the difference between these two? The difference is that the y's are further apart when they're steeper. Okay, the y's are further apart compared to the x's. And so change in y over change in x, sometimes called rise over run, is found by taking two distinct points on your line and subtracting the y values, and then in the same order subtracting the x values. So it doesn't matter which point on your line you call the first point and which point you call the second point. It matters that you do them in the same order both times. And obviously, because the change in x is on the bottom, you can't have a zero change in x. You can have a zero change in y, but you can't have a zero change in x. Okay, and we'll talk about what that might look like later. So just as an example, if you want to find the slope of the line passing between 4, -2 and -1, 5, all right, what you do is you plug them in. And again, it doesn't matter which order this is. If I did this the other way, okay, let's say I start with -2 as my second y, well, then I subtract 5. And that's fine as long as you start also with 4 and subtract -1. You got to watch your signs. Right? So here we'll get what? -7 on top and +5 on the bottom. And that's the same thing as -7/5. And here they did the 5 first and the -1 first, but they ended up with the same thing. And that, of course, makes sense if you do it correctly. Either one, as long as you put whichever y you put first, that x you have to put first also. And as long as you do it in the correct order, you'll get -7/5 both times. Okay, so pretty straightforward. Now, how do we use that slope in order to analyze our lines? Well, one way is that if you want to find the equation of a line, remember that algebra and geometry are related by graphing, and so when we graph a straight line, we'll talk about that in a little bit, but when we graph a straight line, we have to deal with the slope and points that it's passing through. Here, if we're given a point that you're passing through and we know the slope, then we just plug it in to this formula, this point-slope formula. And basically what you can see is if you take the slope formula from back here, right, if you multiply both sides by the x's, you get m times x2 minus x1 equals y2 minus y1. Well, that's pretty much the point slope formula, except instead of y2 and x2, you're just having y and x because they're variables because you only have one point given to you. Okay, so this relationship has to hold, and so what you do is you plug everything in here. Slope is equal to 6, that's your m. x1 is 2, y1 is -5, and so you plug them in. You get y minus y1, remember the grouping, equals m times x minus x1. And that's a perfectly legitimate equation for a line. Okay, that's a perfectly good equation for a line. However, typically what we do in our textbook is that we solve for y, and we'll show you why we solve for y. Lots of y's today. We'll show you why we solve for y in just a little bit. But solving for y, basic algebra, negative is +5. Distribute the 6. 6 times x, 6x. 6 times -2. -12, and then we're going to subtract 5 from both sides, and so we get y equals 6x minus 17. Okay, so Both of these are legitimate equations for a line. This is called the point slope form. This is called the y-intercept form, and again we'll talk about that in a few minutes and explain where that comes from. But because solving for y is a skill you should already have, we're going to go ahead and do it because typically you can get more information off of this, or you can get better information off of this slope-intercept form than the point slope form. Okay, so here's a second example. All right, the slope is given to be -3/2. The point you pass through is -3,7. And so I want you to use the point slope formula. Again, I'll write it down for you. The point slope formula is y minus y1 equals m times x minus x1. You guys have to know the names, okay? This is the point slope form. When you solve for y, it's called the slope-intercept form. And when my math lab gives you problems, or on a test or a quiz when it gives you a problem and it asks you to put it in a particular form, you must put it in that form or it will be marked wrong and I won't give you the point back. All right, because you've got to follow directions and you've got to know what the names are. So write those down, make sure you know the names. You're allowed to use your notes on the quizzes and tests. So make sure that you write that stuff down. Okay. All right, anyway. So there's the point slope formula of the line, there's the information. Pause the video at this point, try to plug in the right spots, and then also solve it for y, and then come back and see how you did. Okay? So, -3,7 is your x1 and your y1. Your slope is -3/2, so we get y minus y1 equals m -3/2 x minus x1. Make sure you put it in parentheses, okay? And so this is the point slope form of the line. Now let's solve for y. We get y minus 7 equals -3/2 x plus 3. All right, negative, negative. Make sure you put it as a plus. Now distribute the -3/2. We get y minus 7 equals -3/2 x minus 9/2. 3 times 3 is 9. The negative carries through. And then we're going to add 7 to both sides. And adding fractions, remember 7 over 1 is the same as 14 over 2. And so we get y equals -3/2 x. -9 plus 14 is plus 5/2. And so that is the equation of your line in what's known as slope-intercept form, solved for y in other words, and that's the way you do it. So hopefully that went well. What is so great about slope-intercept form? The big thing for slope-intercept form is it makes graphing really nice. Alright, so y equals mx plus b again is the slope-intercept form. Assuming you don't have a vertical line, you can write it like that. And so if you want to graph a line given to you that is solved for y, the way that you do it is you start with the y-intercept. Remember what our intercepts are. That's when x equals 0. If x equals 0, then that means this whole thing is nothing, and you just get y equals b. And so whatever this number is with the sign, if this is plus 4, then the intercept is 4. If this is -12, then the intercept is -12. Okay, and then we use our slope to calculate the next point, the second point. We use our slope, which is what? Rise over run. We use our slope to get us from this point, 0b, to the next point. Okay, and then we connect the dots. So let's take a look at how that plays out. We're going to graph the function f of x equals 3 over 5x plus 1. Remember, f of x and y are interchangeable, so if you rather write it as y equals 3/5 x plus 1, I'm fine with that. Okay, so we start with 0, 1. This number is the y-intercept. We plot 0, 1. That's the first step. Now, what's the slope? The slope is 3/5. What does that mean? Well, positive 3 in the y direction is up 3. Up is positive for y. 5, positive 5 in the x direction is right. Right is positive for x. And so we go up 3, right 5, starting at this point. So we count up 3 and we go to the right 5. So starting with the y-intercept of 1, we rise 3, up 3, and we go to the right 5. All right, so this was the point 0, 1. If we go up 3, we have a y value of 4. If we go to the right 5, we have a y value of 5. So the point here is 5, 4. So then we go from 0, 1 to 5, 4, and we just connect the dots. All right, and so we connect those two, put arrows on the end to represent that the line goes on forever, and that's the way you do it. Okay, so once again, using that kind of process, we're going to have you graph the line y equals negative 2x plus 3. Be careful, negative 2 is the slope here, but you need to think of that as rise over run, so how will we do that? And then graph the line. So take a minute, pause the video, and let's see what you got. Okay, so what's your y-intercept? Your y-intercept is the point 0, 3. So we're going to plot the point 0, 3 right here on the y-intercept. I prefer that you label the points. If you're doing them on your paper, I would label them. If you're doing it in my math lab, obviously, it'll be set up for you. And then what is the slope? The slope is negative 2, but we're supposed to think of this as rise over run, so how do we do that? This is not a fraction. Well, we can make it a fraction, negative 2 over 1. And so what does that mean? That means the rise, the change of y is negative 2. That means down 2. And then the run is a positive 1, and that's again to the right. And so that goes over 1. And so we get to this point right here. That point right there is 1, 1. And then we draw a straight line. I'm going to try to do it well. It looks straight. All right, and then of course you have to put the arrows on the end. All right, and you can use a straight edge or ruler, whatever you need to do in order to draw it relatively straight. And I'm not an artist, so it's not perfect, whatever. But again, on the My Math Lab, when you're doing it and you're graphing lines, it's got a tool that you can use. Okay, so that's the process. That's how you do it. And it's very simple, and hopefully that makes sense. All right. Horizontal and vertical lines have some special properties and also special equations. So if the line y equals b, remember y equals mx plus b is the general form. How did you get, where did the mx go? Well, the slope of a horizontal line is 0. Think about it. If you're straight across, if you're flat, you're not going up or down. Your change of y is none. No change of y. So m is equal to 0. If m is equal to 0, see ya. That's all gone. It doesn't matter what x is. Y is always the same. All right. And so as an example, y equals 3. You get a horizontal line straight across. Okay. Vertical lines are a little bit different. Vertical lines look like x equal a. They're the only ones that do not fit the y equals mx plus b form because the slope of a vertical line is undefined. If x is always equal to 3, for example, then whatever points you have on there, if you have 3, 5, and 3, 7, if you try to find the slope of that, what do you get? You get 7 minus 5 over 3 minus 3. That's not defined, right? 2 divided by 0, that doesn't exist. So the vertical line has an undefined slope, and that's why we can't write it in y equals mx plus b form. But we can still graph it. Here's the line 3, and we're going to go straight up and down, best that you can. Okay, no matter what y value you have, x is always 3, and so it's just a vertical line straight up and down through x equals 3. Okay, that's what they look like. All right, finally, one other way to graph a line is using intercepts. We talked about x and the y-intercepts. Remember, for the x-intercept, you let y equal 0. For the y-intercept, you let x equal 0. So we're going to take a minute here, pause the video, find the intercepts, and then see if you can figure out what the line should look like. Okay? Okay, so if you plugged in y equals 0 here and solve for x, you'll get 3x equals 6, so x equals 2. So that means the x-intercept is 2, 0. If you plug in x equals 0 and solve this for y, you'll get negative 2y equals 6 divided by negative 2. And so you'll get y equals negative 3. So that means that 0, negative 3 is your y-intercept. So here's your x-intercept, 2, 0. Your y-intercept, 0, negative 3. Plot those points. Here's 0, negative 3. Here's 2, 0. And then just connect the dots. Draw a straight line through them. Arrows on the end. And there's your line. That's how you use intercepts to graph a linear equation. Okay? So there's a lot of stuff there in section 3, and again, section 4 will continue with linear functions. But go ahead and get started on the homework and the worksheets, and then we'll move into section 4. Thanks.